Okay, so we're on question number 21 now. And we know that the radius is going to be 1. And our x value is 0.8. And our y value is going to be 0.6. Now let's go through why we know this. So we have a point that's not necessarily on the unit circle. It's not recognizable. So we know we have, well, it says the coordinate is 1, 0. So that's why we know that this is going to be, this is 1, 0. This is, and that this is also going to be a point on the unit circle. So that makes the radius 1. So this is 0.8 and 0.6 to find that point B there. So another way of knowing that is r squared is 0.8 squared plus 0.6 squared. So this is going to be 0.64 plus 0.36. It gives you r squared of 1.0. So r is equal to 1. Okay, so therefore, if this is the reference triangle here, sine is going to be opposite over hypotenuse, or y over r. So it's 0.6 over 1, which is 0.6. Cosine is adjacent over hypotenuse, which is 0.8 over 1, or 0.8. And tangent is opposite over adjacent, or y over x, which is 0.6, divided by 0.8, which simplifies to give you, it's like 6/8 or 0.75. For question 22. Now, we are supposed to sketch the graphs of the 6 trig functions. So we do know that between negative 2 pi and positive 2 pi. So we know that cosines ordered pairs are 0, 0. Pi over 2, this is up at 1. Pi is 0. 3 pi over 2, negative 1. And 2 pi 0. We've learned those earlier in this year. So this is what between negative 2 pi and 2 pi is for sine. Now I'm going to actually go ahead and do cosecant right now. And what I'm going to do here is when you graph cosecant, you are going to put asymptotes where the x-intercepts are for sine. So these are all your asymptotes. And then we're going to draw where this max is. This is going to become the min for cosecant. Where the min is, it becomes the max. And that max is going to be approaching these asymptotes. This max becomes the min again, approaching the asymptotes. And this becomes the minimum. The minimum becomes the maximum of the cosecant. So this is what the cosecant looks like. Below, we are given the graph here is cosine. And again, cosine starts up at 0, 1, goes pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi 1. So this is just 2 periods of it. So between negative 2 pi and positive 2 pi. So we're going to do the same thing here for the graph of secant of x. We are going to put asymptotes where those x-intercepts are. Asymptotes. They're not very neat, but they work. And here is the next asymptote. And again, we're going to do what we did with sine in that where the minimum is, it's going to become the maximum. The maximum becomes the, becomes the minimum here. And here's another one. And then you have some partials here. This is going to be this portion of it. And this is going to be this portion of it. So this is between negative 2 pi and positive 2 pi. What secant looks like. Tangent Remember, tangent is sine over cosine. So what happens here is where cosine is 0 at negative 3 pi over 2, at, in blue here, at negative pi over 2, at pi over 2, and at 3 pi over 2, these become asymptotes because the denominator is never allowed to be 0. And then where sine is equal to 0, that becomes an x-intercept. So we have an x-intercept at, here's sine in yellow, at negative 2 pi, at negative pi, at 0, at pi, and at 2 pi. And then you draw an increasing function that approaches these asymptotes. So that is what tangent looks like and how we go about getting that. This is the tangent of x. The last one to do is cotangent of x. And again, cotangent we know is going to be cosine over sine. So what I'm going to do here, and again, probably could have started with this for the tangent one as well, but we'll just start from scratch on the cotangent. Where sine is equal to 0, we are going to put asymptotes. So we're putting asymptotes here, another asymptote here, here, and here. And then when our numerator, which is cosine, when that hits 0, that becomes our x-intercept. And then we are drawing a decreasing function for cotangent. And that approaches the asymptotes. So again, this is what cotangent looks like. So it follows that same process as tangent, where you determine, or using the sine and cosine function, what those values are. All right. The periods of the 6 circular functions. Okay. The period of sine is 2 pi, because it makes 2 pi to do a full revolution. Cosine, again, a full revolution is 2 pi. And you can go back to the last problem to see that. So it's 1 full revolution here in 2 pi. Cosine, 1 full revolution here is 2 pi. Tangent, 1 full revolution was just pi. Again, look back at your graph. Tangent's down here. This did 1 full revolution from here to here is pi. 3 pi over 2 minus pi over 2 is pi. When you look at your graph of cosecant, that period is 2 pi. Secant is also 2 pi. And cotangent, again, is pi. And let me show you why again. Cosecant, from here to here is 1 full revolution. From here to here is 1 full revolution, so it's 2 pi. Same thing from between here and here, which is negative pi over 2 and 3 pi over 2, that's 2 pi. And finally, for cotangent, between 0 and pi. So those are the periods, how long it takes to do a full revolution. Now, question 24, the period of y equals tangent of 8x. So since we have tangent here, and tangent's period is pi, our period is going to be equal to pi divided by this value here, which is 8. For number 25, the value of b, so the cosine bx has a period of pi over 3. So again, our period is pi over 3. So b is 2 pi because it's cosine over the period, which is pi over 3. And 2 pi divided by pi over 3 is 2 pi times 3 over pi. These cancel out. That's going to be equal to 6. 26. The value of c such that y equals cosecant of cx has a period of 10. So we know that period equals 10. And for cosecant, c, just using a different letter, it's going to be 2 pi over the period, which is pi over 5.